In this video, we're going to look at the empirical rule. So let's read the question and highlight given information and goals. So the scores on a college math exam are approximately normally distributed with a mean score of 78.8% and a standard deviation of 5.2%. And we are asked to do two things: label the normal curve below, which we're given, and then apply the empirical rule to answer the questions below, which are right here. So let's start with our normal curve. Okay, so we're given a generic normal curve, okay, and the horizontal axis is labeled, the center is labeled as the mean, okay, and then we see we have 1, 2, and 3 standard deviations to the right. Standard deviations are a fixed number, so these are equal lengths, okay, even though the heights are different. And then we also have 3 standard deviations to the left of the mean. Okay, so first let's label the mean. So that was 78.8%. Okay. Now 1 standard deviation from the mean would be 78.8 plus, we're given that 1 standard deviation is 5.2. So 1 standard deviation more than the mean is adding 5.2 to the mean. So that would give us 84. So this is 84 right here. Now we can use the same idea to find 2 standard deviations above the mean. We start at the mean, but now we want 2 standard deviations more than the mean, so we'd multiply by 2 times 5.2. And we'd have 78.8 plus 2 times 5.2, and this gives us 89.2. And this will be true in general. I'm just going to write this here. The data value will equal the mean plus the number of standard deviations. Above the mean would be positive, below would be negative, times the standard deviation itself. So SD is standing for standard deviation. Okay. So I want you to notice something that makes this a little bit easier. We can always use this, and we'll use this in a lot of applications, but when we're creating this, if 84 is 1 standard deviation above the mean, to find 2, instead of multiplying here, we could just use repeated addition. It's another 5.2 above 84. And that corresponds to our last answer. So we have 89.2. And the next one, instead of going through all of this work, though it's not much work, we can just add 5.2 to our previous result. And we have 94.4 is 3 standard deviations above the mean. Now to go in the other direction, instead of adding, we can just subtract. So up here, we would think of the number of standard deviations as being negative, okay? So we can add a negative, or adding a negative is the same as subtracting a positive. So we'll just start with the mean and subtract 1 standard deviation. So negative 1 standard deviation is 73.6. To move over another standard deviations, we'll subtract another 5.2, which is 68.4. And for the last one, I'm going to subtract one more 5.2 from the previous answer, and we get 63.2. Now let's use this information to answer these empirical rule questions. So according to the empirical rule, approximately 68% of the scores will lie between blank and blank, and we want to find the blanks. So let's note the empirical rule tells us that approximately 68% of the data will lie within 1 standard deviation in either direction. So these values are going to be minus 1 standard deviation from the mean, and then plus 1 standard deviation from the mean. So that would be, just to get kind of an idea, all of the values in here is or are 68% of the data. Okay, And relatively, that looks like a somewhat approximate area. So we just need to put 73.6. So we put the smaller number first, and then the larger number, which is 84. Okay. Then it asks approximately 95% of the scores will lie between what values? Well, the empirical rule says that that's within 2 standard deviations of the mean. So we just need to find the data values for those. Well, that's 68.4 and 89.2. And let's just take a look at this. So if I shaded all of this, okay, so this is kind of like a curvy histogram, but not exactly. 95% of the scores are between 68.4 and 89.2. Okay. And then finally, approximately 99.7% of the scores will lie between, and I bet you guessed it, 3 standard deviations of the mean. So minus 3 standard deviations plus 3 standard deviations, and that would be the values 63.2 and 94.4. And those would be these small areas right here. We're adding on, so it includes all the 1 standard deviation, it includes the 2, and now it includes these little pieces as well. So that would be another 4.7% are within these little pieces right here.